All right, so we'll go ahead and get started here. We're continuing with 4.6. We started this last week. We did the rational zeros theorem. So we're going to kind of review that and continue with the next couple of problems. This is the last bit of new material for test number 2, which is going to be coming up this coming Thursday. So tomorrow we're going to be doing a review and we'll go through the sample test. Okay, so the rational zeros theorem, it's basically just it's factors of the last number divided by factors of the first number. And this is something that is going to give us, excuse me, a list of possible places where the graph crosses the x-axis. It's only for places where it crosses at a fraction. And so the rational zeros theorem gives you a potential list of like all these numbers that we see here, the one that we did last time. We're doing factors of the last number, factors of 8 divided by factors of 3. We listed those out, and then we have to write them as a list. So it does require you to do that in my open math. So you take all the numbers on top divided by the 1 and all of them on top divided by 3, and you get this list. What this list tells you is that the actual graph is going to cross at one of these possible places. So we just have a big list of all the potential places where it could cross if it crosses at either a fraction or a whole number. Now, if it crosses at a square root, this list is not going to tell you that. This just gives you the rational zeros. So with that, the question that comes up here is, how do we know where exactly this crosses? So we'll take a look at that next. We're actually going to be combining the synthetic division that we talked about before in the previous section. So we're going to go on now to the next example here, now that we know that. And this is going to be, a lot of the problems that are in this section are going to ask you 3 parts on it. It's going to ask you to find the list of possible zeros, then we have to actually figure out what they actually are by using synthetic division. And then finally, it's going to ask us to use the zeros to factor. All right, so we're going to go through and do this problem, all the different parts with it, putting this all together here. So first it says, use the rational zero theorem to list the possible zeros. So for this, we want to do factors of -20, and then over factors of 1, because the number in front of the x that has the highest power, there's just a 1 in front of there. So this is what we want to come up with. So factors of 20 will be numbers that divide evenly into 20. So it's going to be plus or minus 1, plus or minus 2. A 4 divides in there evenly. 5 divides evenly into 20. 10 divides evenly into 20, and of course 20 divides into itself. On the bottom, we have just plus or minus 1 only for that. So let me make this looks like a 3, so let me fix that here. This is a 2 right there. Okay, so with that, yeah, so we have 1, 2, 4, 5, 10, and 20. Now we want to take all the numbers on top, and we want to divide them by the 1 on the bottom. So if we do that, we're just going to get the same list that we have on top. So the answer for part A is plus or minus 1, plus or minus 2. We have 4, 5, 10, and 20, and that's it. That's going to be all the possible places where the graph crosses the x-axis. So now the next thing we want to do is it's asking us to use synthetic division to figure out what the answers actually are. So all we have to do is, if we can find one of these works. So in other words, how do we know it works? Well, if we take one of these zeros, put it into the synthetic division, we go through the whole thing. If we get a remainder of 0, then that tells us that number that we just tried is in fact a place where the graph crosses the x-axis. And once that is accomplished, it's going to allow us to take the cube down into a square, and it's something that we can factor. So let's start off with this. We want to test one of these first. So let's try -1, put in the box, and I'm going to put the coefficients for the synthetic 1, 8, 11, and -20 on there. Okay, I'm going to put a bar down below. So this is how we set up the synthetic division. I'm going to try going through with -1 and see what number I get for the remainder. So I'm going to drop this is a review from last time. 1 drops down, we multiply these together and put the result underneath the next column. Then we're adding this together. Okay, so we have 8 plus a -1 is a 7. 7 times -1 is -7. We're adding these together, we get a 4. We multiply those, we get -4. And we add that together, we get -24. Okay, so what that tells us is that -1 is not a place where the graph crosses the x-axis. It's not a 0 because we don't get a 0 for the remainder. So then what you would do is you would try the next one. You would try a 1. 1, 8, 11, -20, and go through that. 1 drops down. 1 times 1 is 1. We're adding this together, we get a 9. Multiply that together, it's 9, goes here. Add it together, we get 20. 20 times 1 is 20. And then, as we notice here, we do get a 0 for this. That means that 1 is our answer, or one of the answers that we're going to have. So we're going to have other ones, but that's one of our answers, is x equals 1. Now, we don't have to keep doing synthetic division and go through the entire list. Once you find one of them that works, then we can stop doing synthetic division, because remember, whenever we do synthetic, it takes their power down by 1. So what I have left here is x squared plus 9x plus 20, and I can set this equal to 0. It was a cube, but because we did synthetic division, that means that this x squared plus 9x plus 20, that's also a factor, which means I can set it equal to 0, and I can just use factoring for that. So that way I don't have to do synthetic division anymore. So I have this, I have x and x, factors of 20 that add up to 9. I'm going to use 4 and 5. Both of those will be positive. Okay, and so then when we set those equal to 0, we get -4 and -5. So therefore, what you would put down for your answer for part B, you have to include the one that we found by using synthetic division. So 1, -4, -5. Now, it doesn't matter what order you put these in, but these would be the zeros, and that's what you would answer for part B. Okay, so I'm going to show you on the next problem something we can do to make this synthetic division a little bit easier, so we don't have to run through the entire list and do all these by synthetic division. There's another way I'll show you that can speed up this process. I'll let you know that on the test that's coming up, I'm actually going to give you one of the zeros first. It'll say, find the zeros using synthetic division, given that x equals like 1, for instance. And so in that case, since one of them is already going to be provided for you, you're not going to have to do all this guess and check work that we did here by trying and running through the entire list using synthetic division. You should only be able to use synthetic once or twice to get the other answers, and that's it. We'll show that with the sample test when we do that tomorrow. I'll show you a problem how that's going to be. But the ones in the homework, they don't give you a starter for that, unfortunately. So we'll have to either use synthetic division, or like I'll show you later, we can use a little technology to help us out with that as well. But for part B, the answers will be -4, -5. Now this part here, you should definitely factor to find the other zeros. I don't recommend using the quadratic formula, because quadratic formula, although it will give you -4 and -5 for that, since in part C we have to factor, it's actually better if you factor in part B, because part of our answer in part B is going to be used to answer part C. So for instance, for this, let's put f of x equals, and then I'm going to put this factored piece that we had from part B in there, x plus 4, x plus 5. I'm going to put that in there right away. Now, we also got an answer of 1 as well. Now, the way that we do that, if we have a 0 and you want to turn it into a factor, you just put x minus, and you just put the number in there, whatever it is. So in this case, I'll just put in an x minus 1. So now this is going to be fully factored. If I set this thing equal to 0, I'm going to get 1, -4, and -5. And in fact, I could graph this as well to see that it does in fact go through all of those. Okay, so that would be the answer for factoring. If I multiply these together, I have 3 x's multiplying together. I'll get x cubed. So that makes sense with what the original problem was. So you could expand all that just to see if it's correct or not, but this is correct here. So that would be the answer for that one. Okay, so that's the 3 parts that most of these questions for homework are going to ask you to, majority of them are going to ask you to do. So let's do a few more of these type of examples. Okay, so here, this time now we have a 4th power. Now, the thing to notice about a 4th power is that when we get our list of zeros and we start testing them and all that, we're going to need to have 2 of them we have to find in order to take this down to a quadratic where we can factor it. Because every time we do synthetic once, it takes this down by a power of 1. So because it's the 4th power, I'm going to need to find, in part B, I'll need to find 2 zeros that allow us to take it down into a quadratic. So we'll get to that a little bit later. First, we want to write down the list of rational zeros. Okay, so we're going to do factors of 6 over factors of 3. Okay, so again, I'm going to find the numbers that divide evenly into 6 and to 3. On top, we've got a 1. Oops, forgot to put the 1 there. 1. 2 divides evenly into 6. 3 divides evenly into 6. And 6 divides evenly into itself. On the bottom, we'll have 1 and 3 for that. We want to take all the numbers on top, divide by 1, all the numbers on top, divide by 3. Now, as we're going through this, if we get a number that gets repeated twice, you only have to write it once down on your list. So we'll take a look at that as we go through. All the numbers on top divided by 1 will just be those numbers, plus or minus 1, 2, 3, and 6. Okay, but now we're going to take all the numbers on top divided by 3. I have 1/3 plus or minus 1/3, and then I have plus or minus 2/3 from that. Now the next one I have is 3/3. Now 3/3 is 1. We already have it on our list, so we don't have to write it again. And 6 divided by 3 is 2. We already have that on our list already, so we don't have to write it again. So if you get to that point where it reduces to something that's already on your list, then you don't need to write it down a second time. If it's written down once, then that's it. That's fine. So this is our total list that we have of factors to try. So again, what I would end up doing here is I would have to do synthetic division 1 by 1 to test all these out. Now there's not a whole lot of factors here, so certainly I could go ahead and do that. So again, what do I mean by testing? Well, that means that I would start by putting in a 1 into here. So we'll do a 1 like that with our original factors. So I'm going to put these down here: 3, -11, -1, 19, and 6. Keep in mind also that if there is a power missing, you do have to put a placekeeper in there, put a 0. This one, we don't have to do that. It's got 4, 3, 2, 1, 0. So that's fine the way it is. Okay. And so what I would do is I would run through and do the same steps again by synthetic division, drop down to 3, and I would be adding with this. -8 times 1 is -8. Add together, we get 9. Add that together, we get a 9 here. We can already tell by going through all this that we can actually stop here because we know it's not going to work, because 28 and 1, that's not going to give us a 0. So we would just move on to the next step and do all that. Now, instead of going through all this work, we need to find the first two zeros that work with this. If we can find two of them that work first, then what that means is we can then make that easier for us. Now, what I'm going to do is I'm going to go ahead and share a new screen for you. What we're going to do to make this easier is we're going to use Desmos in order to graph that. So I'm going to put the function in that we're working with here. Now, we still have to do synthetic division on this. So I don't want to just use the graph to get the entire answer, plus some of these cross at a fraction. So we're not going to tell anyway. But if we take a look at this, see how we can tell by this where the graph crosses. So there's a 2 here and a 4, or sorry, 2 and a 3 where it crosses, and there's also a -1. So the graph is telling us that that it crosses at 2 and 3. So essentially what I'm using here is I'm using Desmos to get the two starting numbers to take it down to a quadratic. And then the last remaining ones, I'll find these two on the left-hand side. I'll find that by doing factoring. So from Desmos, I get 2 and 3. So what this allows us to do is to avoid doing the trial and error checks with synthetic division. There's no need to actually go through every single one of those and go through the entire list when we can use technology instead. So from this, it tells us that our function crosses at 2 and 3. So let's jump back to the notes. Okay, and so synthetic division, we could go ahead and do that, but what I'm going to say is Desmos here gave us 2 and 3. Okay, that means I don't have to test any other numbers on this. I'm just going to use 2 and 3, and that's going to take my thing down to a quadratic. So if I'm using technology, I still will have to use synthetic in the end. So I am still using synthetic division. It's just that I'm finding the starting ones out from Desmos, and you can do the same as well. So first we'll do a 2. Now it doesn't matter which one of these you start with. I'll start with 2. 3, -11, -1, 19, and 6. Because this came from the graph, I'll be guaranteed to get a 0 here if I do this correctly. Okay, so if we do it correctly, then we should get a 0. So 3 comes down. 2 times 3 is 6. We're adding that together. -11 plus 6 is -5, times 2 is -10. Add it together, we get -11. -11 times 2 is -22. If we add that, we get -3 and -6. And as expected, we do get a remainder of 0. So I know for sure that 2 is going to be one of my answers. Now I'm going to do synthetic again with the 3, and I want to take this down to a quadratic. Now how you do that is you use the 3, but instead of using the original 3, -11, -1, and so forth, we're going to use the answer that we got when we put a 2 in there. So I'm going to put 3, -5, -11, and -3. The reason why I'm using the answers instead of the original problem is because if I use the original problem again, it's still going to be a cube, because every time you do synthetic, it drops the power down by 1. Well, this 3, -5, -11, -3, that represents a cubic function, so something raised to the power of 3. So if I want to take it down to a power of 2 where I can factor, then I need to use the answers. I need to use the 3, -5, -11, -3. I need to use that with my other 0 that I found from Desmos. So I'm going to put 3 in there, and this should give me a 0 as well. So drop the 3 down, we'll multiply that. We're adding 9 minus 5 is 4, times 3 is 12. 12 plus -11 is a 1. 1 times 3 is 3. Add it together, and as expected, we get another 0. What I have done is I have taken this down into a quadratic, because now I have 3x squared plus 4x plus 1, and I want to take this equal to 0. Again, for something like this, don't use quadratic formula. I know for some of you it may be easier, but because you have to factor in part C, it's strongly recommended for you to factor in part B, because then what this factors into, that's part of my answer automatically for part C. So for this one, I'm just going to do trial and error with that, since there's not a lot of factors. So 3x squared goes into 3x times x, and the 1 is 1 times 1 there. And since everything is plus, this has to be plus as well. That's really the only way it can be done. And now that's fully factored. We can set these equal to 0. So if I do 3x plus 1 equals 0 and x plus 1 equals 0, I'll get my answers. I'm going to get negative 1/3 and negative 1. So for this, if I want to write the zeros, this is what I would put on my answers. I just put negative 1, negative 1/3, the negatives, and then 2 and 3. And if you look at the graph that we did on Desmos, that's exactly where the graph crosses the x-axis. It crosses at these. Something else I'm going to point out as well, I'll come back to this here, but one thing I want to point out, if you look at the numbers that you got here, every one of these numbers actually comes from the original list that we found by using the list of rational zeros. Negative 1 is on there. We have the 1/3 is there, the 2 and the 3. So that all those come from the list. So the list of rational zeros gives you all the possible potential zeros, but in order to find out what they are exactly, then we have to use synthetic division or use a graph, something like that, to tell us what they actually are. Okay, so now that I've done that, I just need to factor it. So the first part of my answer is automatically going to be what I factored in part B, 3x plus 1, x plus 1. But now I want to put the 2 and the 3 on there as well. Okay, so again, whenever you want to turn a 0 into a factor, you just put x minus and you just stick the number in there. Okay, so I'm going to do x minus 2, x minus 3. And I should have 4 things being multiplied together, because if I set all these equal to 0, I'll get all 4 of my answers that I have. Also, multiplying 4 x's together will give you x to the 4th power. So now this is fully factored with that. So we really use a little bit of technology in order to help us there. So if there's a lot of factors like that, you don't want to go through the synthetic division test for that. You don't have to. You can just actually look at a graph to help. Okay, so let's move on to the next one here. Okay, so next one, we're doing factors of the, so again, we're doing the same parts again, using the same 3 parts. So we're going to do factors of negative 4 over factors of 1. So by the way, when we do this, when we put the plus or minus signs next to it, that's why it doesn't matter if this number here is positive or negative, because since we're putting plus or minus, that takes care of all the plus minus combinations on that. So that's why it doesn't matter if it's minus or plus, we're still putting plus or minus on here anyway. The numbers that divide evenly into 4 will just be 1, 2, and 4, and that's it. On the bottom, I just have plus or minus 1. So then if I just take all the numbers on top divided by all the numbers on the bottom, I just get 1, 2, and 4. I would put plus or minus signs in front of it. Okay, so that's all I get. So I don't have a whole lot of factors to try. So this particular one, we could actually run through our list, and if we didn't want to graph it, we could certainly do this all with synthetic division. So I'm actually going to go ahead and we're gonna do that on this one. So let's do that. Instead of graphing it, let's just use synthetic division for the whole thing. So what I'll do is I'm going to start out with, now remember, when you're doing this, you have to take it down to a square. So we have to find two zeros in order to take it down to quadratic. So first thing I'm going to do is I'm just going to start with a 1. And I'll start with 1 because that's the first number on our list here, 1, negative 1. So let's start with 1. So I'm going to do, I have 1, 4, 3, negative 4, negative 4. Okay, so start off with that. Okay, then the 1 drops down here, and then multiply that, and I get a 1. We're adding that together. I have a 5. 5 goes here. Add together, we get 8. 8 times 1 is 8 here. 8 minus 4 is 4. And we just so happened the first one we tested brought us down to a 0. That's good. Okay, so now from this, if you're testing other ones, since we found one that works, all the other ones that you're testing now, you're going to use 1, 5, 8, and 4 instead. Because if you look, as soon as you find the first one that gives you a remainder of 0, then all the other ones that you test, you're just going to use 1, 5, 8, and 4. And you just want to find any other 0, any other number that you're going to try in here that gives you a remainder of 0. So now that I know that, let's try the next one I'm going to try in the list is, so I'm going to do 1, -1, 2, -2. I'm just going to do all that on this, and I'll see what happens on this next time. 1, 5, 8, 4. Okay, so again, notice I'm using since I already got this to be a 0, all the other ones I'm testing will use 1, 5, 8, and 4. So 1's going to drop down. Times -1 is -1 here. We're going to add that together. 5 minus 1 is 4. Times -1 is -4. We add that. We get a 4 here. 4 times -1, -4. And we got a 0. Okay, so good. The first two that we tried in our list just so happened to work out to where we got it down to a quadratic. So we don't have to do synthetic anymore on this, actually. From here, we can just go ahead and turn this into a quadratic. This is x squared plus 4x plus 4. Okay, so every time you do synthetic, it takes the power down by 1. This is a cube, and then it's a square. Now we're going to set that equal to 0 to find what the remaining ones are. We don't have to do synthetic anymore once we take it down to a quadratic. Now we can just factor it. Okay, so factor it, x and x. Factors of 4 that add up to 4 will be 2 and 2. We get plus and a plus here for that. And then we get x is equal to -2. Okay, so the zeros. Now, since we have 2 of these things here, we get -2 twice, but you only have to put it once. So I'm going to put -2, -1, -1, and 1. Okay, so -2, -1, and 1 will be the answers on that one. So we have a double one here at -2, but you only have to write it down once. So now we want to factor it. So if we factor it, we're going to put the x plus 2, x plus 2 that we got from above here. So again, the whatever thing you factor in part B automatically becomes the answer for part C. Then you have to add a couple more pieces to it here. The other two answers we got by using synthetic were 1 and -1, which means that we're just going to put x minus each of these. So x minus for each of those, x minus 1. And if you do x minus a -1, that's going to turn into a +1. Okay, so we get this right here. You could leave the answer as that, or if you'd like to write it as a square, you could also do so, but it doesn't matter. That's fine. Both of those would be considered correct. So you set that equal to 0, you will get the answers that we got. And then if you multiply it out, you will get x to the 4th power. So it does work out with that. So this is sometimes if the list that you have, the list of rational zeros is small enough, sometimes you might be able to just go right into synthetic division and get the answers that way. But if we have a lot of factors, then it's probably better to look at a graph. Okay, so let's do, so with that one, that's actually it for the 4.6 section right there. Now, since we have a little bit of time, I'm going to go through and do one of these for you on the, I'll just do one of the ones from homework. Okay, so we can have a little bit more practice on that. So we'll do a cube again. And so what I'm going to do here is I'm going to open up a blank one, and we're going to go through the same 3 steps again. Just want to do one more example for you, just so we have enough to do. So I feel like we need one more example. So I'm going to open up a blank page for you here. So to open up a blank. Okay, so blank page. And I'm just going to pull one of these problems off of the homework. So here is, so for this one here, let me write it out for you. So this is like a question 8 from homework that we have. So we've got f of x, they gave us 2x cubed minus 13x squared plus 13x plus 10. We're going to go through the same 3 steps that we were doing already in the other problems. Okay, so step number 1, part A says this is going to be the list of rational real zeros. Okay, so for that, we're doing factors of the last number over factors of the first number. So you want to do factors of 10 over factors of 2. All right, so we're going to do factors of 10, all the numbers that divide evenly into 10, 1, 2, 5, and 10. Okay, so we have that so far. On the bottom, we have plus or minus 1, plus or minus 2. Okay, from here, we're going to get our list of zeros, or take everything on top, divide by 1, everything on top, divide by 2. You take everything on top, divide by 1, you get 1, 2, 5, and 10. Okay. Next, all the numbers on top divide by 2. So I get plus or minus 1/2. 2 over 2 is 1. I already have on my list, so I don't need to write that again. Then I have plus or minus 5/2. And then I have 10 over 2, which is 5. Well, we already have that in the list, so we don't have to write that again. Okay, so we've got that complete. Okay. Part B, it says use synthetic division. If I can spell division right. Division to find the zeros. Okay, so now, okay, next thing we're going to do is, because this has a lot of different factors, I think what we'll do is we'll go back to the Desmos again on this one, just so we have another example where we use Desmos. So what we'll do is I'm going to go back to the Desmos screen again, and let's go to that. Let's go into the Desmos screen. Okay, so here is the problem we were just working on, 2x cubed minus 13x squared plus 13x plus 10. Okay, so I put that in there, and if we look on here, we see it goes through a 2, so it's better to use a whole number if you can. This looks like it goes through 0.5, but let's look at 2 instead. Now, of course, with Desmos, you can zoom out, so there's actually another one over here that we can use as 5. Okay, so since I have to use synthetic division at least one time here, I can grab any of these I want to do synthetic. Now, since it's a cube, I only need to grab one of these to work with my synthetic. So I can use any of these, it doesn't matter. I can use a 2 or a 5. Let's go ahead and use a 2. So I'm going to go back to the screen we were just working on before, and just go back to that. So I'll go back to where we were before. So Desmos tells us that x equals 2 is a 0. Okay, so Desmos told us that, which means that I can now use a 2 with synthetic division. So I'm going to put my coefficients in here, -2, -13, 13, and 10. Drop down to 2. You get a 4 here, add that together. -13 plus 4 is going to be -9 times 2 is -18. Add that together. -18 plus 13 is -5 times 2 is -10. And as expected, we get a remainder of 0. That's what we want. All right. So now that we have this, what's remaining? 2x squared minus 9x minus 5. We want to set that part now equal to 0, and we're going to find the other answers here. Okay, so we want to set this equal to 0, and so for this, we're going to factor it. And this is going to become part of my answer in part C. So I'm going to do 2x and x here to get the 2x squared. Then I want a 1 and a 5. Let's see if that's the right order. 2x squared, we have a 10 and a 1. So yeah, if I make this a minus and that a plus, then I'll get 2x squared minus 10 plus 1 is -9, and then I get -5. So yes, that is correct now as far as the factoring. If I do 2x plus 1 equals 0, x minus 5 equals 0. We get x is equal to -1/2, and x is equal to 5. Okay, so those are my all my answers, the zeros that I would put down for my answer is I would put -1/2, a 2, and a 5. Okay, so those are all the answers that I got. Now, I'm putting these in order from smallest to largest. You don't have to do that. It doesn't matter when you enter those into my math lab, or my open math, I should say. Okay, now that that's complete, part C says use the zeros to factor. Okay, so use the zeros to factor. Okay, so now that I have that complete, what I'll do is first part of my answer. Come on, pen keeps glitching out here. F of x is, let me put this down here. So I have the first two pieces, 2x plus 1 and x minus 5. Okay, so that's the first part that I have. That is the factor piece that I have in part D. And then for the last thing I have here, I'm just going to put x minus, and the 0 that I got from Desmos, I'll put that inside here. So that there would be the fully factored form, 2x plus 1, x minus 5, x minus 2, and that would be all the pieces. Okay, so again, I use the factored piece from part B. I use that in part C. So that's important to make sure you factor whenever you do part B, so that because that way you'll automatically get part of your answer for part C. So this was, again, that's typical, one of the types of questions from homework that you'll do. There's the highest power you'll see here is a 4th power. You won't see anything higher than that. So it's a 4th power. Then when you use Desmos, you can find 2 values in the graph to use with this. And so that's how you can answer that one. All right, so now we're going to go to 4.7, and this is the last section that we have of new material for test number 2. So your test number 2 this week will include this section as well, 4.7. Right, so we'll be doing, again, review. We'll do that tomorrow. Okay, so it says complex zeros. So basically this means that we're still doing something similar to what we did in the last section, except that this time some of the answers you'll get will be imaginary numbers. That's, again, why we had to cover the imaginary number section earlier, so because of this section here. So basically what this means is if it is known that 1 0 is 7 plus 3i, the other one must be 7 minus 3i. Okay, these come in what's called conjugate pairs. Okay, so these come in conjugate pairs. So for example, if you have 7 plus 3i, that means automatically another one automatically is 7 minus 3i. These always come in conjugate pairs. So if 1 0 is 7 plus 3i, then the other one has to be 7 minus 3i. So here's another example that we have with that. If a degree 6 polynomial, they give you these complex zeros. It says, what must the other zeros be? So all we have to do on this question is to come up with the conjugates of all these. So it's just the opposite sign of each of that. So negative I we have, positive 2i, because this is, I'm sorry, we need a 3 in there as well. Okay, so negative I, because that's all we have. This is 3 minus 2i, so the conjugate will be 3 plus 2i. Now this last one over here, we're only going to change the sign. Notice that when I put the conjugate down, I'm only changing just the middle sign only. I'm not changing the sign of any other numbers. So if I have negative 2 plus I, its conjugate will be negative 2 minus I. We don't change the number. We're just changing the number, the sign that's in between the real number and the I. Okay, and that's all you have to do for this one. You just want to write down the conjugates. So just the opposite signs. That's all you need to do for that one. All right. Now this next one, it says, form a degree 4 polynomial with real number coefficients. Now it says that the leading coefficient of this can be an A, so I don't have to find what the exact polynomial it is. That means we did some of these before when we, back in the quadratics section, there was one where it said, it gave us the zeros and then it told us it has to go through a certain point in the graph, so we had to solve for an A value. That's kind of what this is here, but we don't have to do that in this case. It just says that we can leave it a leading coefficient of A, and that's going to be it. So for something like this, what we do is, now it says for this, a 0, a 3 is a 0, and a 5i is a 0. So what you're going to do here is you're just going to put x minus, and you stick the 0 in there, no matter if it's a real number or a positive, a real number or a imaginary 0. We do the same thing. We did this before in the last section. Whenever you have zeros and you want to form a factors like this, algebraic factors, you're just going to put x minus. So I'm going to put an x minus 3 here. I'm going to put a 5i on that one. Now, what I also know about this is it says the multiplicity is 2 if I have a 0 of 3. Now, what that means is that I need to put a 2 on top of the first factor. So whatever the multiplicity is, that becomes the power that you have on that particular factored piece. What I also know about the 0 is it tells us that there's a 0 of 5i, but automatically we should know that there's also a 0 of negative 5i as well. Remember that these always come in pairs. So if they give you one of them, automatically we know that we should have another one of these. So in fact, I'm going to have x minus negative 5 would be x plus 5i that I have there. So it's always x minus whatever the 0 happens to be. So now I have formed the things that I'm going to multiply, but on these problems in my open math, you do have to multiply this all out because it says real number coefficients, which means that I need to multiply this out, and there's a leading coefficient of A that is there, and so that means that there's actually an A out there in front of the whole thing. So I should have put that out front. F of x equals an A times all of this. So we need to multiply this all out. So I'm going to put an A here. Let's multiply out these two on the end first. So if I multiply this, I get x times x is x squared. Now I get a plus 5ix and a minus 5ix. Those are going to cancel out, so I don't have any middle term here. Then I have minus 25i squared. What we remember from the imaginary number section we talked about is anytime you have I squared, you should be turning that into a negative 1. So I'm going to put a negative 1 in there for the I squared. That is going to change this into now A times, we have x minus 3 squared, and then this is going to be x squared plus 25. So now we have this this part. This part here, x minus, let's take care of this. So that really means x minus 3 and x minus 3. And I also have x squared plus 25. Let's multiply the x minus 3s. Let's multiply those out first. So I get a times, that's going to be x squared minus 3 is a minus 6x plus 9. And I still have x squared plus 25 in the end. Okay. So we're almost done now. We just need to multiply these two things together. The a, I'm just going to leave that on the outside. I'll just leave it there out in front. But this other thing, I'm going to multiply that. So I have an a, and then let's multiply this. Basically, you're going to take x squared times these two things, the negative 6x times these two things, and then the 9 times these two things. So let's do x squared times those two things first. We're going to get x to the 4th. X squared times 25 is going to be 25 x squared. That takes care of that. Now we're going to do negative 6x times these two things. Negative 6x times x squared is negative 6x cubed. And then next thing we're going to do, we're going to take negative 6x times 25. That's going to be negative 150x. Don't forget about the x there. Okay, and now we're going to do 9 times both of these things. Okay, so we're going to do 9x squared. And then we're going to do 9 times 25 would be, for that, 225. And that's going to be it for that one on the end. Okay, so now that we have that, we're just going to add the like terms together there. So if we add the like terms together, we're going to get, and we'll still put the a term out front here. So let's move this down again. And then, okay, so we got a times all this. So x to the 4th, we'll put first. We want to add, put them in order from highest to lowest power. So minus 6x cubed we have there. 25 and 9 is going to give you 34. So plus 34x squared. And then I have a minus 150x that doesn't belong with anything else, and then I have the 225. Okay, so that right there would be the answer on that. It's a degree 4 polynomial. It has real number coefficients, as we see here. We have a leading coefficient of a that's out front. You don't have to multiply the a all the way through. In fact, when you do this problem, let me take a look. I believe the homework question has the a in the parentheses already out in front of already. I think you just have to fill in the inside one with that. So let me see here. I want to look at which, yeah. So the one that's in the homework, it has, what it'll have here is it'll have an a in a parenthesis, and there'll be a blank for this. So then you're just going to write this whole thing out. You'll just type that in inside. And so the a in the parentheses are already there for you, so you don't have to worry about writing that. So that's why you don't need to expand or multiply all that out. You can just leave it just like this. So you'll just type all this in right there. All right, so next thing we're going to take a look at is this one right here. We'll jump down to this next one. Okay, so for this here, this polynomial has 1, 0 of negative 5i. Use this to find the other zeros. Okay, so what I know for sure is if 1, 0 is negative 5i, what I know about that is that 5i is the other one I'm going to have, which means that I can form a polynomial with this. I can do x minus 5i, and then that'll be x plus 5i. Right there, x minus negative. Now, we already did this in the last problem. We multiply those together, and I'll just go ahead and just give us the result of what we had before. So in the last problem, we multiplied this out, and we got x squared plus 25. Middle terms cancel out. you get -5 or -25 I squared, -1 for I squared, and you get plus 25. So I get x squared plus 25 would be the polynomial I get that gives you -5i and 5i. Now I want to use this in order to figure out what the other 0 is there. Now, because we can't use synthetic this time because it's an x squared, we're going to have to use long division on this particular problem. The way it's going to be written out is you'll do x squared plus 0x plus 25, and then you're going to do this here, and this already has descending powers, so we can just leave it just like this. So I'm dividing it now. Whatever I get up on top here, I can then set that equal to 0 to get the other answer that I have. So I already know 2 zeros. I know -5i and 5i, but I'll just use this long division to figure out what the remaining one is. So x cubed divided by x squared gives me just an x. X times all this, I get x cubed plus 0x squared plus 25x. There's an x up here that I forgot as well. And now we're going to subtract all this. That's 0. I get 3x squared minus nothing is 3x squared. And then if I subtract this, 25 minus 25, remember this is long division, so you have to subtract when you do long division. This is going to be a 0x. And then we're going to bring down the 75. So that way we have 3 terms here, and we need 3 terms here as well. 3x squared divided by x squared is plus 3. 3 times all this, we get 3x squared plus 0x plus 75. If we subtract all this, we get a remainder of 0 as expected, because if we're dividing by a factor, we should get a remainder of 0, because a factor means it divides it evenly with no remainder. So that's what that means. So now I just have to take x plus 3 and set it equal to 0, and I get -3 as the answer. So this actually would be the answer on this. It asks you for the other zeros here. Okay, and so that's what that means. And so when you write your answer, I'm just going to look and make sure that we have it. Just want to make sure it's I have the correct thing here. So yeah, so it says remaining zeros. So actually the homework says other, instead of that it says remaining, which means we don't want to put 5i as our answer. So for that, when we put put that down here, so let me just put remaining zeros. So I just want to just make sure I do real similar to what the homework says. That way you're not confused on what to do there. Remaining zeros means that we're not going to include -5i in our answer. Now 5i I do need to include, because that we came up with on our own because it's a conjugate pair. So I'll put 5i and then -3, and that's what the remaining zeros are going to be. That's what I'll do to write that out. Okay, so I'll just put down 5i and then the other one that I have. Okay, that's what you want to, that's what they're expecting you to do on that. So you don't want to include the original one. We just want to include the new ones that we find. Okay, so 5i and -3, we found that by going through this process. Okay, now this one says, given f of -5 equals 0, find the complex zeros of this. All right, now this one's easier, because now we can go back to synthetic division again. This is actually very similar to the problem that we did in the last section. So the last section in 4.6 there, we use synthetic to bring this down to a quadratic, and then we can use factoring other methods to solve it. So we're given that -5 equals 0. So because of that, I can just put -5 in directly into here. And I should get, this is saying that if I put -5 in the box, I should get a 0 for my remainder. That's exactly what this says. That's going back to the remainder theorem that we talked about before. Okay. So if I put this in, I should be expected to get a 0 for the remainder here. So 1 drops down. 1 times -5 is -5. We're adding that together and you get 8. 8 times -5 is -40. Add that together. 57 plus -40 is 17. 17 times -5 is -85. And we get a remainder of 0 as expected. What the remaining one is I have x squared plus 8x, not 18, 8x plus 17 equals 0. Now, what makes this problem different than the ones that we did in the previous section is that in the previous section, we were able to factor this, but unfortunately this time we can't, there's not two numbers that multiply to make 17 that add to be 8. So because of that, we can't factor this. So instead, if you can't factor it, then you got to use quadratic formula. So the a value is the number in front of the x squared, that's 1. B is equal to 8, and C is equal to 17. Now we're going to put these into the quadratic formula. So you should only use quadratic formula if you can't factor it. So we have negative b plus or minus the square root of b squared minus 4ac all over 2a. And if we do that, that means that it's telling us that we should get complex zeros. So probably what will happen is we're going to get a negative number underneath the square root. And so then we have to simplify that down and use the standard form with the measured numbers. Let's put our numbers in there and see what we get. We get negative 8 plus or minus. We get 8 squared minus 4 times a is 1, c is 17. All that over 2 times a, the a is 1 in this case. So that's the first step, is just plug everything all into the quadratic formula. Next thing we're going to do is we'll just do some simplifying, and you want to simplify down as much as possible with this. Negative 8 plus or minus the square root of 64. That's going to be minus 68, would be 4 times 17 over 2. Inside, we already see that we will, in fact, get a negative number inside there. 64 minus 68 is negative 4. And we'll just keep on going with this. We want to simplify this down. Negative 8 plus or minus. Now, the square root of negative 4, the square root of 4 is 2. But because there's a negative number underneath the square root, that means we're going to have an I. So that's going to turn into 2i. We're dividing this by 2, which means that each of these can be divided by 2. Okay. A common mistake here is I see students just divide the first one only and just do negative 8 divided by 2 and make 4. But remember, because all this is divided by 2, each of these individually need to be divided by 2. So don't forget to do that. Negative 4 plus or minus I. Okay, and that would be in the proper form, the standard form of a imaginary number like that. We have the real number part, and then we have the I part that comes second. Okay, so that would be your answer there. So it gave you the 0 here, and then that allowed us to, we had to use quadratic because it couldn't be factored, and that ended up giving us this as our answer. Okay, so that's gonna be it for that. All right, so this one here, all right. So we're given this. It says find the complex zeros of f, then write f in factored form. Okay, so this type of one is like the ones that you have in the homework. There's one that is similar to that. Okay, and so for that one, here's how we're going to do it. So this is the last question we have. Now this one, I do want to mention that when you do this in the My Open Math, there is a written solution that's there, so you should be able to see that appear when you're doing that, and you'll be able to get a little bit of assistance with it. It's similar to the one that I'm going to show you now, but there's just let you know that that is available on this particular one, just because this will give you another example for doing that. Okay, so let's go ahead and jump into this one now. Now, if you take a look at what it is, it kind of resembles a quadratic in a way. Okay, if you look at it, because you have three terms, and normally with a quadratic you would have a 2, a 1, and a 0. Well, this I have a 4, a 2, and a 0. I want to try and factor this and try and get it into a regular quadratic, because in a regular quadratic, that's going to make that easier then to solve if I have it that way. Now, if you know how to factor it directly from this form, by all means, go ahead and do that if you know how to do that already. But most of you you may not recognize or understand how to do that. So here's what we're going to do. What I'm going to do is this term right here, I'm going to turn that into a u. Okay, so I'm going to let u equal x squared. Now, if I square both sides, I get u squared is going to equal x squared squared, which equals x to the 4th. So now what I'll do is this one here, I'm going to let that equal u squared. So by using these substitutions, I'm going to turn a 4th power into a square, and that'll make that easier as far as I can try some factoring and different things there. So with that, I'm going to change the problem into u squared plus 362u plus 361. And then that I'm going to set that equal to 0. Okay, so now I have this. So it's a lot easier to solve now, since I have it as a quadratic. Now from here, this actually is something that I can factor because I have the u's. So I'm going to put a u here and a u there. I'm looking for numbers that multiply to make 361, but add to be 362. Well, that can only be 1 and 361 is the only combination that's going to work. So now if I multiply this, I get u squared, I get 361u, and I get another u that gives me the 362u there, and then 1 times 361 is 361. So now this is going to be fully factored. Okay, so, but now we're not, now that I have this complete, remember that originally we said that the u is the same thing as x squared. So now I can replace the u with x squared. We're not going to use x to the 4th because x to the 4th power is only when you have u squared. We don't have a u squared here. Each of these ones inside the parentheses was just a regular u. So both of those turn into just regular x squared for each of those. So now this is factored. So if I multiply x squared plus 1 times x squared plus 361, I'm going to get the original thing that we started with. Again, if you already recognize how to factor it and go from the first step directly down into the line that I have here, then by all means go ahead and do that. But sometimes the substitution technique, that can help a little bit with that. All right, so now that I have that is done, okay, we're going to now each of these individually I can set equal to 0. So I have x squared plus 1 equals 0 and x squared plus 361 equals 0. Now I'm going to use this square root method in order to solve each of these. So I'm going to subtract 1 and I get x squared equals -1. And if I take the square root of both sides, so square root of x squared and square root of -1, I get x is equal to plus or minus, because remember when you take the square root, you do get a plus or minus there. And that's just going to be an I. Okay, square root of -1 gives you an I. Okay. Now I'm going to do the same thing with the other one. I'm going to move this over to the other side. I'm going to take the square root of both sides separately. When I do, I get plus or minus. Like that. So square root of both sides. Square root of x squared gives you an x. And then this I get plus or minus the square root of -361. Well, that is going to be the square root of 361 is 19, so plus or minus 19. But then I get a square root of -1 is an I. Okay, so I get an I there as well. Okay, so basically first thing it asks for is the complex zeros. The complex zeros are going to be plus or minus I and plus or minus 19I. So that's the first thing it asks for is the complex zeros. And so with that, you can just go ahead and write that down. Just list those out. So that's the first step, is to list those. Okay. And I think in this one, it just says to separate your answers with commas. So when you put these into the homework, it's just going to be I, negative I, 19I, negative 19I. You'll have to just put those all in with parentheses there. Okay, so that's how you'll do that. Okay, now that's the first part of it. Now there is another part of this too. It says up here, then write F in factored form. Okay. Now, yes, the factored form, we do have this right here. Technically, we have x squared plus 1 and x squared minus 361. But what they want for the answer, or what they're expecting to put in here, is they actually want an answer with i's in it as a result. Okay, so with that, what we'll do, so we'll do factored form. Okay, so we have this f of x equals, and what I'm going to do here is just put x minus for all these, just like that. And I'm just going to stick in the i's. So I have x minus I, then I have x minus negative I will be a plus I right here, and I have 19I, and then I have plus 19I on the end right there. Okay, so I have x minus I, x plus I, x minus 19I, x plus 19I, and I have all those written out there. And that's the factored form that they want you to put in for these. They do want you to include the i's when you do that. So that's what we have as your two answers. Okay, so again, this one, there should be a written solution that you'll see when you do these problems. You'll be able to see that, and that's like one of the aids that you have when you do that for the question help. You should have that on there. So that should be available for you. Okay. All right. So that's going to be it then. That's actually all of 4.7. So now we've completed everything that we need to finish as far as what's going to be on the test number 2. Okay, so your test number 2 is just basically going to cover everything since the last test. So you're not going to see stuff from test 1 on test number 2. So basically, the new material started the first lecture after the last test. That's basically where the new material is on here. We are going to do a review tomorrow in class. We're going to go through the sample test. We'll do one version of the sample test all the way through, and then any questions you have, we'll answer those as well. And then as a reminder, there is no lecture on Thursday this week. So we never have a lecture on the day of the test. Last time was a little bit of an anomaly because we had a goof with the Zoom didn't work. And so I just did an extra review session on the day of the test, but normally we don't do that. So this week, as long as we can have a regular review tomorrow, and Zoom's been working fine. So that should be okay. Knock on wood, of course. Then that means Thursday we'll not have a lecture. That's just left open all day for you guys to take the test. Remember, you have a 24-hour period. You should have received the Scratchwork copy from me. I sent that out yesterday to you, so you should now have that. So Monday this week is when I sent that out. So you check your Canvas email. You should have that in the Scratchwork that you have. The same rules apply for test number 2. You want to make sure that you scan a copy of your written work to me within 30 minutes of completing your test in my Open Math, just like last time. And If you can use your own scratch paper if you don't have access to a printer and can't print out the one that I sent you. But if you have a digital writing tablet, you can also just write your answers on the digital version and just turn that in as well. That way you don't have to print anything out. You can just use the digital copy I sent you guys, the PDF. All right. So with that, I'll go ahead and end the lesson here unless anybody has any questions. Does anybody have any questions for today? All right, seems like nobody has any questions. I'll go ahead and end this meeting. Enjoy the rest of your day. See you guys tomorrow.